Two ships P and Q are moving on straight courses with constant speeds. At one instant Q is 80 kilometers from P on a bearing of 220 degrees. 3 hours later Q is 36 kilometers due south of P. Show that the velocity of Q relative to P is 19.1 kilometers over hour in the direction with bearing 63.8 degrees, both correct to three significant figures. We will use these two formula and this is a parallelogram, and if this angle is alpha, its adjacent angle is 180 minus alpha. First, here is ship Q, then here our idea that let ship P be the reference system. So it's not ship B is not moving in this system. First Q is here, bearing 220 degrees. It is here to the north, and its distance is 80 kilometers. Then it's south, and this is the distance from P. And 220 minus 180, it's 40 degrees. And here in this triangle we can use this formula. Not important, the parenthesis is not important, but it's useful because the students miss the order of the operation. So this we apply this formula here. X is this side, and after calculation we get that X is equal to 57.3 kilometers. Velocity is equal to distance over time. So this value over 3, we get that the relative velocity is 19.1 kilometers over hour. Then we will calculate alpha. We use this formula, sine of alpha over sine of 40 is equal to the opposite side, 36 over opposite side of this angle, this value. So we get that alpha is equal to 23.8 degrees. Alpha is not equal this angle because this side less than this side, so its opposite angle less than 40, so alpha isn't equal this value, and we need this angle bearing means to the north, so 40 plus alpha is 63.8 degrees. Find the shortest distance between the two ships in the subsequent motion. This is the shortest distance between the two ships. We can calculate this from this right triangle. This is opposite of this angle. So y is equal to 80 times sine of 23.8. So we get that the shortened distance is 32.3 kilometers. Given that the speed of P is 28 kilometers per hour and Q is traveling in the direction with bearing 105 degrees, find the bearing of the direction in which P is traveling, the speed of Q. So what we've got, this is our figure. The velocity of Q relative to P, it means VQ minus VP. It is here. This is, for example, VQ, VP, and this is VQ minus VP. And here is VQ2, and these are the same. So we know that the speed of this difference is 19.1. We've calculated this earlier, and its bearing is 63.8 degrees. It is here and here. So speed of P, it is here, and Q is traveling in the direction with bearing 105 degrees. This bearing means to the north. So it is this is here, this angle, and from this triangle 105 minus 63.8, we get this angle, and we can use this previous formula. We calculate this beta, sine of beta over sine of 41.2 is equal to opposite side. So opposite is here, and this is the opposite. So we get that sine of beta is equal to this value, and we get 26.7 degrees, or 180 minus 26.7. It is here, but beta is not equal to this angle because this value less than this side. So beta less than 41.2. Yes, and we know beta. Beta is here too. So bearing of P is beta plus 105, so it's 131.7 degrees, because this is 105 and this is 105 too, and this is the bearing of VP. And we need speed of Q, so this we need this side. We can calculate this angle, 180 minus 41.2 minus beta, so it is here, and we can apply this formula, VQ over 28 is equal to sine of the opposite angle over this sine of this angle. So we get that VQ is equal to 39.4 kilometers per hour.